for joining us on Science Spotlight. Today, I'll be speaking with Dr. Elizabeth Stahl and Connor Sushita, researchers in Jennifer Doudna's lab, who are helping to set up a COVID-19 testing facility. Abby and Connor, why don't you guys start by telling us a little bit about what the Doudna Lab does usually?
Yeah, well, thanks for having us, Jenna. Yeah, so we're, Abby and I are both in the Doudna Lab, and really the central focus of our lab is really on these CRISPR-Cas systems that have been really popular and have sort of revolutionized gene editing. And in particular, I think our lab can really be divided up into three parts. The first being the discovery of new CRISPR-Cas systems. So, people are constantly searching for these new systems, these new molecules in bacteria and archaea and even phages and viruses now. And then I think the other, the second part would be sort of understanding how these molecules work. So there's a lot of biochemistry and genetics and genomics and structural biology. And then the third part of our lab that Abby and I are particularly interested in and do our work in is really applying those technologies that have been discovered and characterized, and how we can use it as a tool for things like genome editing.
So how has your lab's activities changed in response to COVID-19?
Yeah, so I mean, like everyone else in California, where we're located, and most of the people in the nation were in a shelter in place. So we are no longer allowed or are doing our normal research activities. So for me, that's stopping doing my thesis research for my graduate school. But since our institute that Abby and I both work in, and that the Doudna Lab's part of, the Innovative Genomics Institute at UC Berkeley, has taken a couple of very COVID-19 specific projects to work on doing diagnoses as well as developing technologies to hopefully help combat this infectious disease. And so a number of us in the lab, Abby and I included, are volunteering on that effort. So it's totally different research, totally different testing than what we normally do. But there are some techniques and technologies and know-how that sort of are able to sort of translate from our normal research into what we're doing currently during this pandemic.
So what exactly does setting up a COVID-19 testing lab entail? What were you able to carry over from your normal lab practices, and what have you had to bring in to set that up?
Sure, yeah, I can speak to that. So essentially, we started building this COVID-19 testing lab about 3 weeks ago. We just went live on Monday, which I think was April 6th. And so essentially in 3 weeks, we had to build a COVID-19 diagnostics lab from the ground up. And so I first heard about this event or this new diagnostics lab by a Google sheet that went out on Twitter looking for volunteers. And so essentially they said the Innovative Genomics Institute is starting a COVID-19 testing lab. We're looking for volunteers who would help to perform the diagnostic tests. And so I signed up immediately. And through that, I was able to actually get more involved in starting the lab from the ground up. And so this is really a effort that takes a lot of different skill sets. And so we had one team developing our lab developed test. So that's the technical team that Connor and I are part of. And essentially that meant coming up with a diagnostic platform which would be authorized through the FDA for emergency use during this pandemic that we could use in-house to diagnose COVID-19 samples. But once we have a test, you really have to build this whole structure around the test and know, how do we get patient samples in? How do we keep track of them? How do we report those diagnoses back to the clinicians? And so we had to become CLIA certified. And that was a huge process. Luckily, there's been some regulation changes during the pandemic to allow a CLIA lab to extend their license to a new place. So the Tang Center here at UC Berkeley extended their CLIA license to cover the Innovative Genomics Institute. And we worked really closely with some clinical laboratory specialists over at the Tang Center to really sort of develop that. And that involves training our volunteers in a lot of biosafety and also taking into account their personal protection with enough PPE. We even had to do HIPAA training since there's going to be protected health information potentially coming into the diagnostics lab. And then I guess once our test was developed, we have to also send it back to the FDA and let them know that we are going to be testing samples and that we have validated our tests against some other clinical labs that are up and running. And yeah, I think that is really the biggest thing. We also had to develop a laboratory informational management system that could organize all of our data in a way where these samples are de-identified and they can then be reported back to the physician's office after the test is done. So this full effort coming together in 3 weeks is really remarkable. And it took a team of at least 20 people here at UC Berkeley. Mostly these are scientists who are just sort of repurposing their knowledge. In coming together, we had team meetings every single morning for the past 3 weeks to make this a possibility, and also people working around the clock.
That's amazing. I think people tend to maybe underestimate how much is involved in testing, you know, beyond just what you have to do technically. So it sounds like you guys, as opposed to using somebody else's developed and approved test, you're actually developing your own. So can you talk a little bit more about how those tests are performed? What kind of samples do you use? What sort of equipment and reagents do you need?
Yeah, sure. So it's, you know, it's really been a mix, I think, of, you know, we've definitely been, you know, communicating with other, you know, clinical labs who are doing this COVID, you know, the SARS-CoV-2 testing, as well as, you know, try to sort of optimize it in our own hands and, you know, make sure that, you know, we're capable and able to do it. So, you know, right now we're using a, you know, quantitative, you know, reverse transcriptase PCR method, where we are, you know, we're not physicians, so we're not, you know, taking samples ourselves, but we're working with clinics and physicians who are, you know, swabbing, you know, patients and you know, potential, you know, people who may have been infected. Those swabs are inactivated and are brought to us as an inactivated virus. We go through a process that we've optimized to do the RNA extraction from the virus, so to isolate the genome from the SARS-CoV-2, and then go through our, you know, quantitative reverse transcriptase PCR to essentially have a way to, you know, measure the amount of viral genome when we probe for certain parts of, you know, the known SARS-CoV-2 genome. And, you know, once we have that readout, you know, we can, you know, work with, you know, a lot of our information systems, people who have been helping us to, you know, give that information back to the clinicians so that they can interface with, you know, the patients and the people they swabbed. And so, you know, right now, this is sort of a mix of, you know, manual techniques and optimization, which is really, you know, where the skill sets that, you know, Abby and I and other people helping out, you know, really come into play, having done some of these techniques before. But we're really actively trying to, you know, scale up a automated system for this. And so we've been really fortunate to both have and have been loaned or donated some, you know, automated equipment, you know, mostly sort of liquid handling robots to be able to, you know, hopefully automate the system, increase the throughput. And so we're, you know, really actively and really rapidly trying to, you know, move the whole process for sample intake, RNA extraction, and reverse transcriptase quantitative PCR into an even more automated system.
So what's the throughput and the turnaround time right now, and where do you hope it will be once you have all of this automation in place?
Yeah, I can speak to that. So we went live on Monday, as I said, and Connor's also mentioned our manual pipeline that's being used right now. And so essentially that means we have a team of volunteers in the lab doing the sample acquisition. We are using one liquid handling robot to basically take the sample from the tubes and array it into a plate for us. And then we can manually do the RNA extraction and the qPCR. And so every day we're getting more samples returned to the IGI. So it's very exciting. Right now we have the capacity through this manual pipeline to do a couple hundred samples a day. But once we bring on the second liquid handling robot, that will increase our throughput to up to 1,000 tests per day. And really that's just because we're using a different size plate for our PCR test. Instead of 96 samples per assay, we'll be able to do 384 per assay. And so having the robot being able to pipette these very, very small volumes with a low error rate is what's going to allow us to really get our higher throughput out.
That's amazing. That's higher, I think, than some people would expect. And it's great to hear that it could increase by such a dramatic scale. You've already talked a lot about some hurdles that you've had to overcome to get to this point. Are there any challenges you foresee in the future or resources that you'll think you'll need or that might become limited to continue to make this effort a success?
Yeah, sure. I think, as far as challenges go, we're still definitely working on a lot of the, automation, as we've mentioned, as well as sort of the information systems. I think that's, a challenge for us. We've had a lot of, great people, outside of, academia helping us out, but, those are definitely new things to all of us, working with patient samples, working, with all this regulatory, compliance. And so that's something, that I think, is a challenge that we're sort of actively facing, as well as, getting this sort of automation to sort of increase, our throughput. For the time where we're still doing things, manually, it's definitely a challenge to continue to bring on more volunteers to, help with this process. We had, when, like Abby mentioned, when a Google form was sent out asking for volunteers, we had an amazing response. I think we had something like 800 people, write in saying that, they were willing to help. And so, I think, actively organizing, those volunteers and sort of, increasing the amount of volunteers we can have to help to increase the throughput, while also, making sure we're doing it safely, and making sure, that we're not putting each other, at risk or other people in our lives at risk. And so, scaling up this process while still maintaining safe social distancing, I think is something that we're still, trying to figure out in terms of personnel management and scheduling. And I think, resource-wise, the big question for us is, we don't really, and, I don't think anyone really knows how long this will, last for. So, a lot of effort, from our institute has been put into, sourcing the right, reagents, kits, PPE, plates, all this stuff that we need. And we have a fair amount of it now. But, just depending on if this lasts, weeks or months or who knows, those resources are finite. So, I think that's a issue we'll sort of have to face as we sort of, get a better understanding of how long we'll actually be doing this clinical testing for.
So one last question, since you guys have blazed this trail, are there any lessons learned that you'd like to share with researchers at other institutions who might be interested in setting up similar labs?
Yeah, sure. I think having those resources available for others to learn from, I think there's an online Slack community and a Twitter community that is really involved in sort of sharing protocols and details for these things. And we are going to also put some of our work online very shortly for others to be able to access and ask questions about. But I think the biggest lessons learned are that really identifying a place at your institute that can extend a CLIA license is key. Working with those clinicians early on to identify the bottlenecks that might arise, because there's a lot of regulatory red tape around patient health information and how it can be accessed and reported. And so I think a lot of institutes are already sort of built with their electronic medical records in place. And it's hard to tap into those things, even in a pandemic, in order to do that. And so, I think identifying the clinical partners is key. And then, the other thing that I wanted to say is that we are developing our own lab test, but it's based on the Thermo Fisher available PCR assay that they put out for SARS-CoV-2. But anytime that you change anything very minusculely, like even changing from a nasal swab to an oral swab, the test has to be completely revalidated. And so that is how we have sort of developed our own test, just by making these very small changes. And so being aware of sort of every time you make a change, it has to be revalidated, coming in with like a really strong action plan of what you would want to change so that you don't have to keep revalidating things. And luckily we haven't been in that position at all, where we've had to revalidate things, but being aware of that, I think, is key.
That is excellent information. Thank you so much for sharing. You mentioned Twitter, I think. Is there a particular channel where people are turning for research info?
There is a particular Slack channel. Let me see if I can find it really quickly, because I joined it and I found it on Twitter. How do I see all of my different workspaces?
I can follow up with you too, and we can put it in the comment section for anybody.
That would be great.
Awesome. Thank you, Abby, and thank you, Connor, so much for joining us today. And to everyone out there watching, thanks for tuning in. Stay tuned for more future chats about ongoing COVID research. Stay safe.
Thanks, Jenna.
Thanks, Jenna.